So let's see if we can sort out 53, which has several bits. First, we want to parameterize a line perpendicular to the plane 2x minus 3y is z through a point 137. Then we want to find out where it hits. And then part C seems to ask how far apart are a point plane. Hopefully part A and B will help me with that. Maybe. Probably. Hopefully. All right, let's start with A at least.
Yeah.
So I want a line perpendicular to a plane through a point. So what do I need to make a line?
Normal vector.
Okay. So I want to think about my line, right, as some starting point plus slope times time, right? So where's your line going to start?
At 2, well,
Negative.
2, negative 3, negative.
Negative.
137.
It's going to start at 137. And what's the vector that you're trying to give me, Mel?
2, negative 3, negative 1.
2, negative 3, negative 1. And why am I putting that over here? Because it's the slope, right?
Yeah.
It's a vector perpendicular to that plane. So that's going to be the slope I'm looking for. And then I'm going to, what else do I need here?
T.
Okay, I need a variable. Okay, great. So here's my line. That's the answer to part A.
Yay.
Cool. Does that make sense?
Yeah.
Okay.
Where was the hit?
How about B? Where does it hit? How about a different but similar question? What if I thought, when does it hit? Would that be more helpful?
All right. When t equals 0.
No. When t is 0, where is this thing?
It's still at the start.
Yeah, it's at the starting point, right? Which is not necessarily in the plane. I should probably check that though, because that would be a really stupid error to make. How do I check if 137 is in the plane?
2 minus 3?
Just plug
them
it
in, see if you get 7.
Yeah, I just want to know, is this point already in there? If this point's already in the plane, I have no work to do, right? That would be a really happy coincidence. So how do I check if that's in there?
Just plug it in.
Plug it in, right? So is
2 minus 9.
2 minus 9?
Not 7.
Not 7.
Not 7. Shit. Who's worth a shot? How do I figure out when it hits? Set something equal to something. Good man. How about this? Rewrite your line as x, y, z.
Yeah.
Why would that be helpful?
Now we have
Because of plane,
3 functions.
XYZ.
Yeah, the plane's in x, y, z. If I rewrite my line in x, y, z, I can take this and stick it in there. Not dot product. I know it's going to be perpendicular.
Okay.
It's going to be perpendicular to the normal vector at least. And then the dot product with the other things is only going to tell me kind of how far apart they are.
So you just do x minus 1 and x minus 3. So, or y minus 3.
Okay, hang on. What?
1
What's
plus
this one?
2t. 3 minus 3t.
Oh.
And 7 minus t.
Okay, so that's my x, y, z, right, for the line. If I want to know when it hits, I take that stuff and plug it into the
Plane equation.
plane equation,
And solve
right?
for t.
And then we'll solve for t. So I'll get, what am I supposed to do with the x?
Plug in 1 plus 2t. So
Okay, so I've got 2 times 1 plus 2t
Negative 3 times
minus 3 times 3 minus 3t
equals 7 minus t.
And why don't I have a question mark here?
Because we don't know if they're
I would be putting a question mark if I was worried that.
it
What?
doesn't satisfy the equation.
Yeah, if I was worried if it did satisfy the equation, right? Here I have a variable though.
It's really confusing me. I thought that was a 7 on the 2x minus 3y equals 7.
That's what I thought
This
too.
whole time I was like confused.
Yeah, I did
I was
too.
comparing it to the other 7s. I'm like, that's gotta be a 7.
Sorry, my bad.
Alright.
Alright, so I don't have a question mark because I think there probably is such a t, right? So how do I lay my hands on such a t? Don't think too hard on this one. Yeah, that's like algebra, maybe 2, so I have to distribute a couple of times. So, what do you get?
2 plus 4t minus 9 minus 9t plus. Yeah, that's sure. Sorry, plus 19.
Okay, equals
7 minus
7 minus t. Okay,
Add by terms.
okay. Combine my terms. So that reads like I've got 13t minus 7 is 7 minus t. T equals 1. Cool. All right. So when I got t equals 1, what do I do with that?
Plug it in.
Wait, why? Into where? Oh my god.
That one to find the line.
Okay, good. You want to know, right? This is just a time. I don't care about when it hits, right? I care about where it hits. So I should plug t equals 1 into the line. So if I plug t equals 1 into the line, I'm going to get L of 1, right?
3, 0, 6.
Which is going to be the vector 3, 0, 6, or the point 3, 0, 6. Cool. Quick double check, see if it's on the plane. I like that from Mark. So let's see. 2 times 3 minus 0 is 6. Check. Awesome. Good, it's on the plane. It happens to be on the line. Perfect. That's the answer for
Part B.
part B. Okay, part C.
How far apart?
Yeah, so far what I have is this, right? I have a plane someplace out in the world. I have a point someplace over here. I have a line that's perpendicular to the plane that goes through that point. Okay, see that? And now I'm trying to get out a ruler, right? And figure out how far is that? Yeah. Chuck it in the distance formula. Chuck what in the distance formula?
Those 2 points.
This one and
137.
137. Why?
Well, it's saying how far apart 137 and oh.
Intersection.
Yeah, but why does that answer the thing about the
It's
plane?
because 3 zeros or 137 is on the plane.
Uh-huh.
306 is on the plane.
306 is on the plane.
Okay.
That's because the line's perpendicular to the plane.
Yeah, and it's the closest point on the plane, right? Because the line's perpendicular to the plane there. You guys see that? If I just found any old point, like, for instance, the origin is also on this plane. You guys see that? But it's over here. So of course, it's further away than the point that's perpendicular,
Yeah.
than the point that's on the perpendicular line. You guys see that? So when I'm asking how close are the point in the plane, I need to find the closest point in the plane, which is what A and B led me through, and then calculate the distance formula. So for part C, I need, what? What's the distance formula work?
Square root of x squared
plus y squared plus z.
x minus x naught. X2 minus x1.
Okay, how about this?
Sure.
X's, Y's, and
Z.
Z's all squared, added together? Okay, how far apart are those 2 points in the X?
2, -3, -1.
2, -3, -1? Does that seem like it makes sense to you guys? Also, right, that's the displacement vector between the 2 points. You guys see that? And then I dot product it with itself. So this is also telling me how long the displacement vector is. Of course it is, right? Because there's the displacement vector, and of course it's that same green one. You guys see that? So all told out of this jazz, I'm going to get the square root of 4 plus 9 plus 1.
Which is 14, square root of 14.
So I get the square root of 14.
Yeah.
Cool. Questions, things?
I like that question.
You like that question?
Should put it on the test.
It's a very cool question because it kind of helps you out, right?
Yeah.
If they had just asked part C, right? How far apart are this thing and this thing?
Well, you don't have much to work.
Yeah, you have to kind of intuit that you should find the line perpendicular to the plane and then figure out where it hits and then take the distance formula between those, right?
Yeah.
The other way to do it, right, is to take this point in this plane, set up a general distance formula, or maybe a distance squared formula, and then run like minimization or something on it. But that's of course going to be kind of nasty, right?